Hello everyone, welcome to Coding Complexity. Hope you guys are doing great. Today we have another interesting problem on binary trees. Let's see what the problem is all about. Longest zigzag path in a binary tree. Let's just read the description, then we'll jump onto the understanding of problem statement and we'll look at how are we going to approach the problem statement. So let's just read the description. A zigzag path for a binary tree is defined as follows. Choose any node in a binary tree and a direction. If the current direction is right, move to the right child, otherwise to the left. Change the direction from left to right and vice versa. Repeat the second and the third steps until you can't move in the tree. Return the longest zigzag path in a tree. Okay, let's just quickly jump onto the understanding of this problem statement and what approach are we going to use. Then we'll look at the code. We can choose any node and a direction. So let's suppose we have chosen this node, or let's say this node. Then we can choose any direction. Either we can go left or we can go right. Okay, then we'll have to move to the direction as chosen. So whatever the direction we have chosen, we'll have to move at that direction. So let's suppose we are at the root node. Let's say we have chosen the right direction. We'll jump from this root node to the right child. Now switch the direction for the next step. At this child node, whenever we'll have to make a next jump, then we cannot make the jump here. Since we are already coming from the right side, then we'll have to make a switch as stated. So we'll go to the left direction. Continue the above two statements and return the longest path. If you guys can see, so this is a zigzag pattern that we are moving this and this direction. Let's suppose we have chosen this particular node. Then let's suppose we have taken the right direction. We have moved to this, then left, then again right. Now since we cannot move here, since there is no node, we cannot move here, and this is also not possible since we are already coming from the right direction. Here, what are the number of steps that we have taken? 1, 2, 2, and here 1, 2, 3, 3. And also another thing that we can move, let's say left direction. Then from this node, since we are coming from left, then we'll have to make a jump to the right node. If you see, so this zigzag pattern consists of 2 steps. Now we'll have to return the maximum of these. So the maximum of these would be 3. This would be our answer. Now let's understand how are we going to approach these kind of problems. Let's suppose we are at this root node and we have made a decision to jump to the right node. We have chosen the node, we have taken the direction, right direction. Now we have made a jump from this root node to the right child. Now we'll have to make a switch for the next step. At this particular node, what all things we need to make a next jump, I must know from which direction that I'm coming from, correct? Otherwise it won't work. Since our statement is we'll have to move the direction whatever it was chosen. Now we'll have to make a switch for the next step, right? At this particular node, we must know what direction that we were coming from. So one state that we need is what direction we are coming from. We are coming from right direction, and we also need how many steps we have taken so far to reach this particular node. From root to right child, we have taken 1 step. As per the third statement, we'll have to switch the direction. So at this state, we already know that we are coming from right direction, so we'll make a switch to left direction. Now here what state we'll have? We'll have left, and we'll pass the number of steps that we have taken so far and increment it by 1. So here it will be 2. This zigzag patterns comes at the 2-step process. Another thing, every time we'll have to switch the direction that we are coming from original direction. Now let's just suppose that this is my root node, then I don't know what the direction that we are coming from, and I have taken 0 steps till now. Since this is my root node, this is what I'm assuming right now. Now we'll make a jump to this. Similar jump that we have taken from root to this node, we'll consider this as a root node and we'll make a jump to this right child. Again, similar to this, we are passing right and we have taken one step. Again, at this node, we already know that we are coming from right direction and we have taken one step so far. So we'll make a jump to the left direction and we'll have the state here left and we'll increment it by 1, the number of steps. Again, at this particular node, we know that we are coming from left direction, then we'll have to make a jump to the right direction and increment the steps. So we have right and number of steps that we have taken is 3. We are knowing that we are coming from right direction, then we'll make a jump to the left direction. But since there is no node, it won't be happening. Similar, assume this is my root node and we'll make a jump to this node. Then what we'll have here is right and number of steps that we have taken right now is 1, since we are assuming this as our root node. At similar fashion, we'll be doing here also, that we'll be moving to this direction. Here what we have right now is that we are coming from left and the number of steps that we have taken so far 1. Now from here, so we'll make a jump to the right node. We are having right and number of steps 2. If we look closely, 1, 2 and 3. Out of these 3 states, we'll have to return the maxima, which is 3. Now let's jump onto the code. Welcome back, guys. What we have understood till now is at each node, what we need to know is what is the previous direction that we were coming from and number of steps that we have traveled so far. Take the maxima of those steps and return. So let's just quickly define our global variable for our answer, maxima. Let's just put a default value as 0. We'll quickly return this one, max. Let's define a method called traverse. Since we are traversing the tree, let's define the traverse and we are passing the root. Now what we'll have to pass the direction and the number of steps. Now assume from this root node that we are going to the right node. So let's jump onto the right node. We have chosen, let's say we have chosen the right direction. Right. So we'll move to the right node and the number of steps that it will take to jump to the right node is 1. And what direction that we are moving. So let's take a boolean and understand from that perspective. Assume if boolean value is coming true, then we are going left direction, and if boolean value is coming as false, we are going right direction. Okay, so let's pass the false here. This depicts that we are moving to the right direction. Copy this one, and since we'll also have to move to the left node, then left node, and we'll change it to the true since we are going to the left direction. Now void so we are getting here root, we are getting the number of steps that we have taken so far, and we are getting the boolean. Let's treat it is left. If true, then we are coming from left direction, otherwise coming from right direction. Let's write the base condition. If root Now let's take the maximum. We're gonna take the maxima at each step. If we are coming from left direction, is left, then we have to move to the right direction. Steps will increment the number of steps and will flip the direction that we were coming from. Since we were coming from left direction, now we are going to the right direction. So we'll just simply flip the boolean flag, and we'll also traverse to left direction. But since we are not switching the direction, since we are coming from left and we are again going to the left, then we cannot increment the steps here. We'll reset everything and we'll just send whatever the direction that we are going, left and left. Similar fashion, let's do for the right. So if this is false, then we are surely coming from the right, then we'll have to move to the left. Traverse to left, steps, and we'll have to flip the flag again. Since we were coming from right direction, then for left we'll have to make it left. Again we'll traverse to right node again, but we'll reset it. We'll pass it as it is. It seems all right to me. Let's just quickly run it once. So this is working for all the cases, test cases. Okay. Let's do one more optimization. If the right node, or let's say subsequent left, right nodes are null, we don't want to make unnecessary recursive calls. So just put a small optimization. Root.right is not equal to null. In the similar fashion, we'll do it here, here, here. So we are passing left, left, just quickly correct it, left. Let's just run again. Yeah, it's working. Let's just submit. It works. Cool guys, happy coding.